Hello everyone, my name is Elizabeth and this is the Mastering Electronics lab for the inverting amplifier. So here we have our op-amp chip and we have it powered by -5 and +5 voltage source. And so here's the input square signal to the amplifier. And so we have also R2 and R1 connected to here at a ratio of 12:1, so that our gain is 12. However, we have a power going from -5 to 5. Here we have channel 1 measuring the input signal, and then we have channel 2 measuring the output signal of the inverting amplifier. And so if we look at our waveforms, we see that here the channel 1 is the input signal, and then we have channel 2 showing the amplified signal of the square wave. So it is inverted and it's amplified, and this red cursor marks show our slew rate. This is the follower circuit, and so here we have the op amp, and we have it powered by -5 volts and +5 volts, and we also have channel 1 and channel 2 on the input and the output signals of the op amp. On this follower circuit, we have the negative terminal of the op amp connected back to the output of the op amp. And so when we measure this on the waveforms is we can see that channel 1, which is the yellow, and then compare it to channel 2, which is the output, and we see that the slew rate is determined by these red marks, which show us change in amplitude over the change in time, and this is what we get. So this is the differential amplifier circuit. Here we have the op amp, and here we have the resistors connected to it. So here we have 1, 2, 3, and 4. We have the 2 input voltages coming in, the 2 sources coming from these 2 resistors, and so that goes into the op amp, and then we have the negative and the +5 volts that power the chip, and we have channel 1 and channel 2 also connected. And so if we take a look at our waveforms, what this circuit does is that it will amplify the difference between the 2 signals. And so as you can see, this blue line is flat, and that is because if we look at the 2 input voltages, they are very similar, and so their difference is minimal.